dx equals du over negative 3, what's my next step? Replace two things. What two things do I replace? My u, so I'm going to circle that, and my dx. Okay, so guys, this over here, we worked this just because we could get a legend. Using this legend, we're going to replace two things, our u and our dx. Okay, now that we know what those are, we're going to come over here and we're going to replace them. Okay, and our goal is to get all u's over here. That's our goal. We're doing a change of variables. Okay, if I could get all these to be u's, then it would just be hopefully an easy antiderivative problem. All right, do I have all u's here? My x's don't cancel out? Oh no. What am I going to do? What am I going to do? Back substitution. Okay, actually, the first thing you would do is look at the problem and say, maybe I picked the wrong u. Does that make sense? Okay, maybe I picked the wrong u. But if you take the derivative of this, which is negative 3, you can see that these x's are not going to cancel out. So you kind of get a hint that this is not a normal problem, it's a back substitution problem. And what that means is I need to replace this x in terms of u. So I come back over here, and do you guys see that 3x is actually equal to 1 minus u? Do you agree with that? Okay, then what does that mean x is equal to? 1 minus u quantity over 3. Is everybody good with that? So I take this information I have about x, and I move it to this side. And if I rewrite this problem, what I get is the integral of 2 times x, but x is now 1 minus u over 3 times u raised to the 1/2 times du over negative 3. Okay? And as ugly as this looks, okay, we can actually make it look a little bit better. Any suggestions?
Take out scalar number.
Okay, yeah, take out the scalar number. What's the scalar number in here, though? Do you see it? It's a little harder to see than usual. What's the scalar number? Negative 2 over 9, right? So I'm going to pull out negative 2 over 9. And then what I have here is 1 minus u times u to the, positive 1/2, sorry about that, du. All right? So right here, this is just the integral of 1 minus u times the integral of u to the 1/2, right? No, don't do that. Why is this not okay?
That's the product rule. We don't know
Yes,
that yet.
that's the product rule, and there's no such thing as an easy product rule with integration, okay? Let me just give you a glimpse into the future. Your product rule with integration, okay, is actually another integration.
Whoa.
Okay, so it's not that easy. Okay, so it's something that you don't want to do. It's called integration by parts if you want to go look it up, okay? But you cannot do a product rule thing here. If it's a product rule, if it's multiplication, you can't do it. But guys, can I get this into all addition or subtraction?
Yes.
Yes, what do I need to do?
Distribute.
And guys, that's going to be the key on your test, okay? You might have to FOIL, but FOIL really is a form of distribution, okay? FOIL or distribute. And if I distribute this, okay, something really beautiful happens. I get u to the 1/2 minus u to the 3/2 du. And do you see, I thought I got to do one problem, but oh boy, I get to do 2, okay? All right, do you guys see this is doable, okay? What am I going to do? This should be back to the first day of antiderivatives when I did this online. I'm going to add 1, divide by the new exponent. This new exponent is 3/2. When you divide by 3/2, you multiply by 2/3. So this is going to be 2/3 u to the 3/2. Really here I'm going to carry down the minus sign. Okay. This here I'm going to add 1. Let me do it in a different color. I'm going to add 1. So my new exponent is 5/2. So I divide by 5/2. If you divide by 5/2, you're really multiplying by what? 2/5. So this will be 2/5 u to the 5/2. Okay. Don't forget, Charlie, and don't forget that this whole thing, had to be multiplied by negative 2/9. Everybody good with that? Not just the first term, but the whole thing. The negative 2/9 need to be multiplied by the whole integration. All right, so I've integrated it. I've got u's. Am I in good shape? Is this a good answer?
It's not the right one.
Yeah, it's a good answer, but it's the wrong answer. Okay, what do I need to do? go back and plug in u. What was my u? Is it 1 minus 3x?
Yeah.
Okay, so I'm going to go back and do 1 minus 3x raised to the 3 halves minus 2 fifths, 1 minus 3x raised to the 5 halves. And guys, right here, this is negative 2 ninths c, but negative 2 ninths c is just some other constant, right? So I'm going to call it c. If you put negative 2 ninths c, I'm fine with that too. Yeah.
So on mine, I didn't take out a negative 1. Would that still be all right?
Yeah, so then all your signs are opposite. Yeah, perfect. Okay. Any questions on this? All right, let's go ahead and pass up your warm-ups. And let's talk about your homework, I think, from last night. So let me see what we have here. Pull out your homework, guys. Let me run by and do a quick check. But here are the odd homework. And if you did all of your homework, let me know, because I am going to give you extra credit if you did all of it. So, because what we're going to do is, I told you guys you could do all of it, but I'm actually not going to assign it because there's way too much going on. So,
what if I did some of it?
all of it.
Did you do all of it?
Good job. All of it.
I did not do all of it. I did a lot of it.
Why not?
Because we were only supposed to do rounds.
You're so quite off. Yes.
I also had
No.
just like
No.
1,
Okay, man.
2, 3, 4, 5, 6. I only didn't do 6. Could have gotten extra credit, Brent. 6 problems. It's all that separates me from David Chu.
It's all that separates you from like one.
Yeah.
You did like 1,000 reasons actually.
That's the extra credit. Yeah. I get to eat your soul and eat your beautiful.
That's not the cool one. I was right there.
Sure it is. But Avery's there. He said something cool out.
What are you saying about me?
I said you're not cool.
Oh.
I'm sorry.
You don't think Avery's cool? I think Avery's cool.
I think Avery's pretty
My
cool.
mom told me I'm cool.
Well, your mom's a liar.
You're
Ooh.
stupid. You're
My
dumb.
mom's not a liar.
No, I said I think you're super all the calculus homework.
Huh? What? Huh?
Oh,
What? What? Huh? Huh?
That's what I thought.
Huh? What? Huh?
What?
Huh?
Oh.
Huh? What? What? Huh?
Oh,
Huh?
shut up. You're so annoying. I hate you. I'm gonna give you a concession.
Haley.
Or
B.
what happened? Okay.
Or
Most of it. Okay. All right, guys. Check the subsequent problems, guys. Check your work, please. Guys, let's be nice to each other in here. Let's get it clear. I'm the only one who's allowed to be mean.
Come on, a B.
Come on.
Come on, a B.
Is 35?
Yes.
Oh, there's 11 there. Is that right? Oh no, no, I checked. I fixed that one. Is this one not right?
Whoa.
I might be wrong.
Look at your work, and I can help you if you don't see it.
Because you work number 33 as well.
Yes.
Oh no, I circled the wrong thing. Okay.
You good? Okay,
Yeah.
33, and then Carla, which one did you need help with? 41. Okay, 41 and 33.
Oh yeah, please do 33.
Killing it. Murdering it cold.
Okay, someone needs 33, right? Okay.
Really?
X minus 10.
Mathematically.
Okay, guys, here's 33. 33. That's a 3. Okay, x minus 10. Was it raised to the 10?
Yes.
Okay, dx. All right, what's my u equal to?
X minus 10.
Okay, what's the derivative of that?
1.
1. And what's dx?
Du. Over 1.
Du over 1.
Just du.
Okay, what two things do I replace here?
Mathematically.
My dx, right? And my u. So this becomes the integral of x u to the 10 du. You good with that?
Yes.
Do my x's cancel out?
No.
Oh no, what am I going to do?
Something else.
Back substitution. Actually, you go back and you try to set your u equal to x, but setting your u equal to x isn't going to help at all. You could try it. But what we're going to do is we're going to say, you know what? Do you see from this problem here that x is actually equal to u plus 10, right? So then you're going to go and replace this. So this is going to be u plus 10 times u to the 10th du. And maybe it'd be better if I don't put these in parentheses. It doesn't really matter. But it's a little bit more obvious after I do this. Okay, what's the product rule for integration? We don't know. Okay, so what are you going to do? You're going to distribute. Guys, when you get stuck on these problems, you would just distribute. Okay, so that's what you'll get. Be careful. Sometimes when you do so much work, you think you've already integrated, but you haven't even integrated. Remember, guys, zip your pants. Okay? All right, so we're going to add 1, divide by the new exponent, add 1, divide by the new exponent. So my answer is going to be u to the 12th over 12 plus 10u to the 11 over 11. Don't forget Charlie, and don't forget to substitute your u's back, and you're done with that problem. Okay, what other questions did we do? Was it 40? 41. Okay, guys, let's look at 41. So 41 is going to be the integral of 2x squared minus 2, integral of, square root of that. Okay, so what's your u equal to, guys? Okay, what do you do next?
Take the derivative.
Take the derivative. And what do you do next? Solve. Solve for dx. What two things did I replace, guys?
dx.
My dx and my u. So here's my dx. Here's my u. Let me go back and rewrite this problem. So I have 2x squared minus 2 times the quantity. This is just u, right? So u to the 1/2 times du over 3x squared minus 3. Do my x's cancel out?
Yes, they do.
Why, yes, they do. How do you see that, though?
Because you pull the 2 out of
You
the
can
left.
factor it out. Yeah.
Right.
This is really 2 times x squared minus 1, and this is really 3 times x squared minus 1, right? So actually, they factor out. So I have a 2/3 u to the 1/2 du. And then, can you guys take it from there?
Yes.
Okay, so that's what you do there. That's a little bit tricky, so make sure that you see that you could do that. You might have to do something like that on the test. Okay, so I'm glad you did this work, this problem. All right, any other questions for this homework? Okay, so I'm not going to grade the rest of this, the evens, but I will post the solutions online. Okay, it's very good practice for their test. All right, so I'll post the solutions online so you can check it and do it at home for fun. All right, let's talk about Mr. Riemann Sums. Here we go. This guy named Riemann, okay, he figured out that if you approximate the area under the curve, you actually get an integral, which is kind of cool. So we talked about, when we approximate slope, okay, when we get the slope at an instantaneous point at one point, that's called the derivative, okay. And if we get the area under the curve, it's actually an integral. So let me illustrate that for you guys, the difference between a derivative and an integral, and then we're going to move on to how we approximate an integral. Okay, so before we did integration, we said, hey, if we wanted to approximate a slope of a tangent line, or if we wanted to approximate a slope at a point, okay, what we had to do is we had to draw a secant line. Do you remember this? We had to draw a secant line.
Yes.
And this was at x, and then we went out to x plus h. Okay? And then what we said was the slope at this point right here, the slope at f of x, this f prime of x, it's approximately equal to, because if we didn't know the function, we'd say it's approximately equal to f of x plus h minus f of x over h, right?
No.
The average rate of change. Okay? But this distance right here is h. So how do I get the exact derivatives? I would make h what?
Approach 0.
Yeah, approach 0. So if I took the limit as this went to 0, what I would get is the exact derivative, right? The exact value of the slope at that point. Okay. If I wanted to approximate it, I could use average rate of change. But if I wanted the exact value of that slope, I would actually have to take the limit. And so we do the same thing for integrals. Okay. For integrals, okay, f of x, if I wanted to know the area under the curve from a to b, okay, that is actually the integral, okay? But the way Riemann said to do it was he said, you know what, approximate this area, okay? And the way you would approximate it is he drew a bunch of rectangles, okay, under the curve. And they don't have to be under the curve, but he drew rectangles to approximate the area under the curve. And he added all of these rectangles together. And they don't have to be equal subintervals. I drew them equal here, but one could be a fat rectangle and one could be skinny. And what he did was he called these letters, like this was delta x1, this is delta x2, this is delta x3, delta x4. This height here, do you agree that this would be, well, I guess if I called this x1, this would be f of x1. Like if I called this point here x2, like if I said this was x2, that y value would be f of x2. Does that make sense? If I called this value here x3, then this y value here would be f of x3. If I wanted the area of each of these rectangles, I added them together. That'd be an approximation of the area under the curve. So that would be f of x1 times delta x1 plus f of x2 plus delta x2, and so on. Does that make sense to you guys? Okay. So the way we write it, though, is we write the summation of x of xi times delta xi. That makes sense too, right? As I goes from 1 to however many i's there are. So we'll say the number of boxes, the number of rectangles are. I goes from 1 to n. Make sense so far? Well, that's an approximation, but guys, how would I get like the exact sum? The exact sum. So how would I make this like even more exact? I would take the delta x and make it do what? Yeah. As delta x approaches 0, okay, then I would get like an infinite number of n's here. Does that make sense? Or, so sometimes you see delta x approach 0, sometimes you see n goes to infinity. Either one would be fine, okay? And this would actually be equal to the exact area under the curve, which is actually, and it turns out, the exact area under the curve is the integral of f of x dx, okay? From, actually, you have to give it some limits. From, this point to this point, a to b, okay? And what we're going to talk about today is how to get these Riemann sums, how to find the approximate area under the curve. Pretty soon in the future here, maybe tomorrow, I'm not sure, I got to look at what I'm doing, but we're going to start finding how to calculate this part, the exact part. But today, we're just going to do this part. How do we find the approximation? All right, so go to your notes. Look at the second page in your notes, so the back of page 1, okay? And you have a table in your notes, okay? I want you to take a look at that table. Where is my table? Here, take a look at this table. I want you to go ahead and plot these points first, okay? So on part A, we're going to plot these 5 points. 1, 2, 3, 4, 5. So 0, 30. So make a little chart. 0, 30, 3, 37, 6, 45, 9, 54, and 12, 65. Go ahead and do that. Okay, so this is going to become our curve. And what we're going to do is we're going to try to approximate the area under the curve, and we're going to use different methods, okay? We're going to use the left-hand method, the right-hand method, the midpoint method, and the trapezoid method. So I'm going to try to show you guys all these methods. Okay, the left-hand method goes like this. You have these points, and what you're going to do is they want, if you look at part B, you want 4 rectangles, and you want to use the left endpoint. Okay, this is called a left-hand Riemann sum. Okay, so what we're going to do is we're going to get 4 rectangles. So do you see one rectangle is going to be from 0 to 3, another rectangle is 3 to 6, another is 6 to 9, another 9 to 12. That's good with that. I need 4 rectangles, but it says pull from the left hand. So I'm going to come up on my left side and use that left-hand number to make my first rectangle. Okay, here's my second rectangle. I'm going to pull up on the left side. Okay, hit wherever my function is on that left side, pull straight across, and that's going to be the y value for my second rectangle. You guys see how I'm making these rectangles? And then the next rectangle will be, I'm going to pull up on the 6, okay, hit that 45, okay, come straight across and make my third rectangle. And then finally my fourth rectangle is going to be using my x equals 9. Do you notice I never used 1 point? Right? If you do a left-hand Riemann sum, you're never going to use the right-hand number. And if you do a right-hand Riemann sum, you're never going to use the left-hand number. Okay, so let's go ahead and figure out the areas of each of these rectangles. So do you see the first rectangle? So this width down here is 3. This width, 3, 6, and 3, the difference is 3. This width is also 3, and this width is also 3. They're not always the same, but in this situation, the way they gave it to us, they are the same. And we're just going to calculate the area of each rectangle. So it's 3 times 30 plus 3 times 37 plus 3 times 45 plus 3 times 54. And you're going to have to use your calculator for this test. This next test is half calculator, half not. Okay, but for the Riemann sum problems, you're going to need a calculator. You add all these together, okay, and I have the answer here. You should get 498. So you guys can check me on that, but that's what I'm getting. You don't have to have units unless they ask you for units. For part B, this is the area under the curve. If this is a velocity, if this is speed, if y is speed, and x is time, then what you have is meters per second, or this is feet per second times seconds. And so the area under the curve is actually going to be feet. Okay, it's the distance that you traveled. Okay, which is the same thing that's going to happen. This graph is basically the same thing that's going to happen when you do your assessment. Okay, you'll get a graph something like this, but yours will probably go up and down. Okay, and you're going to get an approximate area under the curve. Okay, any questions about left-hand Riemann sum? Number one wrong thing students do, okay, if they know how to do this at all. Some students don't know how to do it. But if you know how to do it, see if this makes sense to you. Some students, instead of pulling 3s, remember this is 3, and this is 6, and this is 9, and this is 12. So what some students would do is they'll put 3 here, 6 here, 9 here, and 12 here. Okay, be careful with that, because even though I say that, I always have students do that every year. Okay, so make sure you're actually getting the area of the rectangle, not just pulling the x values. All right, let's do the right-hand Riemann sum. Okay, so same points. Go ahead and do a fresh graph, guys. Fresh graph for letter C. So go to your letter C. I'm going to do the same thing for letter C. And I'm going to hit these 5 points. So 0, 30. 3, at 3, I'm going to put 37. I'm going to plot 37. At 6, I'm going to plot 45. At 9, I'm going to plot 54. And at 12, I'm going to plot 65. Okay. Letter C says, actually, this is a right-hand Riemann sum. And how many rectangles does it say? Is it 4 rectangles still? Okay, so we're going to do 4 rectangles. You can see if there's 4 rectangles, then again, I'm going in the same subintervals that I had before. Okay, but this is right hand. I'm going to pull from the right-hand value. Do you guys see that? So that's a right-hand Riemann sum. So my first rectangle, I'm going to pull from the right side, and I'm going to go all the way up to 65. My second rectangle, I'll pull up at 9, and that's going to go up to 54. Okay. My third rectangle at 6, I'm going to pull up to 45 because that's a value at 6. And my fourth rectangle, I'll pull up at 3, and that's a value at 37. And so do you see I never use the left-hand value? Okay, because when I pulled over from 37, I kind of took care of the value at 0. Okay, and then you do the same thing. You add all these rectangles together. Okay, so this area of the first rectangle is going to be 3 times 30. No, that's not right. What is it, guys? 3 times 37. Thank you. 3 times 37. The area of the second rectangle is 3 times 45, right? Area of the third rectangle is 3 times, did you get 54? And then the area of the last rectangle is 3 times 65. You put all of that into your calculator, okay? And this is going to be the approximation using a right-hand rule, okay, of this table, okay, of this function. And what did you guys get? Did anybody do it? I have it somewhere here. I just need to figure out where it is. I am getting 603. Okay, so this answer is 603. And if you were asked for units, it would be distance because it's velocity times time. It would be distance. Okay, so this is 603 feet. Now, another question they could ask you is this. Is this approximation that you made, is it an under approximation or is it an over approximation? It's over, right? Because you can see all of your areas, right? They overfill the area under the curve, okay? So guys, you need to know this for your test, also for AP exam. You say this is an over approximation, because, and you need to be able to justify it. And the reason is because the function is increasing and you're doing a right-hand Riemann sum. So right-hand sum. You could probably just say right sum, but anyway, over approximation because f is increasing and you have a right-hand Riemann sum. Now if you think about it, if f were decreasing, think about it, let's draw f decreasing just real quick. If f were decreasing and you did a right-hand Riemann sum, you can just draw it and see what's going to happen. Is it going to be an over approximation or an under approximation? Under. Do you see it? So you can kind of sketch it and see that it changes. If this were decreasing, then there'd be an under approximation. Go back to your part A. Your part A, was it an over approximation or an under approximation? Or part B, sorry, part B. Yeah, this was your picture for part B. Okay, you would say here that this is an under approximation. Okay, and your reason would be because f is increasing and what else? And left-hand Riemann sum. That's what you would say. Okay, so I have that in my notes. And you can take a look at it tonight if you need to. But this is an under approximation part B because f is increasing and you have a left-hand Riemann sum. All right, let's do midpoints. Okay, we're going to use the same things, and we're going to do part C. And part C says do a midpoint method. And actually, how many rectangles does it say, though? It's actually nicer. 2 rectangles. So we're going to do midpoint and 2 rectangles. All right. So guys, go ahead and sketch your picture. Once again, you have 0 at 0:30, 3:37, 6:45, 9:54, and 12:65. Okay. But this time, instead of dividing it into 4 parts, I'm going to divide it into what? 2 parts. Okay. So do you see I'm going to have only 2 rectangles. Okay. And you see one rectangle will be like right here, right? And the other rectangle will be like right here. I can see the base of the rectangle. I don't know how high to go up. But this is called a midpoint method. So where do you think I'm going to go up to? The midpoint. So guys, the midpoint between 0 and 6 is 3. Do you see that? So come up on the 3 and use the value for your 3 as your height. So there's going to be my first box right there. Okay? So where do you think the midpoint method is going to take me on the second box? What's the midpoint between 6 and 12? 9. So I'm going to pull up to the 9 value, which turns out to be 54. And there's going to be my second rectangle. Okay? And then you do the same thing. Now it's a geometry problem. You're going to find the area of the rectangles. Okay? I want to say the midpoint method is probably the most missed method on the test, just because actually if you don't do it a lot, it's really hard to figure out how you get that midpoint number. Okay? And all you'll do is you'll say, okay, this area of the first rectangle is 6 times 37. Do you guys see where I'm getting that? And what's the area of the second rectangle? 6 times 54. Okay? You get your calculator, you'll add those together, and let me see what I get. My magic calculator here tells me my answer is, oh darn, I erased it. I have no idea. I erased it from last period, so I have no idea. Okay, but you guys can do that. I trust that you can do that. Okay, did anybody get an answer for that? What? What is it, Danny? 546? Okay, 546. All right, and if they asked you for units, this would be feet, okay, because it's feet per second times second. All right, the last thing they could do is ask you for a trapezoid method, okay?
Would they ask if that was an over under part?
Oh, midpoint they would never ask you.
Okay.
Yeah, midpoint they would never ask you. It's too hard to tell. So just left hand or right hand they would ask you. Okay, what time do we get out of here, guys? You guys are in so much trouble.
Yes.
Well, we'll just work until people show up in the hallway. I have it somewhere. 10:06? Okay, people will start walking in the hallway. It's probably less than that, but that's fine. Okay, because the other classes I barely had any time. Okay, so guys, let's look at the example at the bottom. Okay, and this is the trapezoid method. So what you're going to do is the same thing. Okay, you're going to plot these points. So 0, 1. Okay, and guys, you really don't have to do it to scale, but the closer you get to scale, the easier your problem is, but you really don't have to do it to scale. Okay, so I have 0, 1, then I have at 3, I have 2, and then at 4, I have 3, so here's 4, I have 3, and then at 7, I have 5, so I skip over a lot, and this value is 5, and then finally at 9, I have 4. Okay, so you end up with this up and down kind of thing, okay? The trapezoid method, what you do is instead of making rectangles, what shape do you think you make? Trapezoids, and then you just find the area of the trapezoid, okay? So what I'm going to do is you connect these dots like this, and there's my first trapezoid. Do you see it? Okay. If you don't see it, do this. Okay, because that's what it is. It's a sideways trapezoid. It's a trick. Okay, it should be called the sideways trapezoid method. Okay, and then your next trapezoid is like you connect the 2 and the 3 points, and you see it's a long, skinny trapezoid. Okay, and you got to turn yourself sideways to see it. And then the next trapezoid is right here, comes down this way. Okay, and your final trapezoid is right here. Okay, and this is a trapezoid method. So instead of finding the area of a rectangle, we're just going to find all of these areas, but they're going to be the area of a trapezoid. Remember your trapezoid formula? It's base plus base divided by 2, and you multiply by your height. Okay, base 1 plus base 2. All right, guys, remember we're turning sideways though, okay? So let me label this trapezoid 1, okay? Do you see the length of this base?
Yes.
It's 1. Do you see that? Plus, right? The length of this base is 1. What's the length of this base here? It's just your y value. It's 2. So it's 1 plus 2, all divided by 2 times. The height, guys, is this. It's always just the subinterval length. So what's the height between 0 and 3? What's this length here? 3. So your first area is going to be 3 over 2 times 3 over 1, which is 9 over 2. You guys see that? That's the area of your first trapezoid. Then you add the area of your second trapezoid. And this is very tedious, but it's really just like geometry, okay? So let's get the area of this second trapezoid. All right, again, you got to turn yourself sideways. What's the area? What's the length of this first base, the top base? 2 plus, what's the length of the bottom one here? Do you see it's 3? Take that, add them together, divided by 2. Okay, this is a little bit trickier. Bless you. What's the height of this trapezoid? It's this subinterval. It's just 4 minus 3. You see that? Yeah, so it's just 1. So this is 5 halves. Okay? And that's going to be the second trapezoid. So let me look at the third trapezoid. Okay, again, you guys do it. Base plus base, all divided by 2, times this height. And the height is this subinterval here. Okay, that's the height of the trapezoid. It makes a right angle with the base. So 7 minus 4 is 3. I'm getting 12 here. Can someone second that? Okay, good. And then finally the fourth trapezoid here. Okay, so the fourth trapezoid is going to be, again, base plus base. So I'm getting 5 plus 4, quantity divided by 2, times the length here of this subinterval, which is really the height of the trapezoid. And I think that's 9 minus 7, right? So that's 2. So I'm getting 9 over 2 times 2, which is 8. 18 over 2, which is just 9 back. Someone check that for me. No? Yes. Okay. So then add up all these numbers, guys. So this right here, do you see that's 14 over 2, which is 7, right? So my answer is going to be 7 plus 12 plus 9, 28. Okay. And so that is the approximation using a trapezoid. Okay. Pretty easy, right? Okay. So that's that problem. The other thing that they might ask you is, or that's helpful to know, is this formula here. This won't work because these subintervals are not equal, but if you ever wanted to divide things into equal subintervals, you can use a formula. So let me see if we have one here. We just did that side. Let's just go ahead and look at the other example, the next example on your right side. It says 4 equal subintervals. Okay, so what we're going to do is, let's see, this problem here. Okay, you're going to draw this picture, and you're going to get the area under the curve. Okay, so this picture here, the function x squared plus 2, so that's just a parabola but shifted up 2. You guys good with that? I shifted up 2. But guys, make this parabola like really stretchy. It's going to help you. I'll just let you know. Make it really stretchy. And we want the area, see if this makes sense, from point A to point B. So that's from 0 to 8. These are your limits of your integram. Okay, 0 to 8. And this function is x squared plus 2. All right? If you want 4 equal subintervals, there's a formula. It's delta x equals b minus a over n. And that tells you how big each subinterval needs to be. And this should make a lot of sense. This is your b right here. Like this is your b value, and this is your a value. So this is 8 minus 0 over the number of boxes that you want. So you want 4 boxes. So each of your intervals is going to be 2. So I'm going to come over here and go 0, 2, 4, plus 2 is 6, and 8. And those are my 4 boxes. You guys see I did that? You could probably do it just like with your brain too. But this is a formula that will help you do it with. Okay? We want a left-hand Riemann sum. Okay? So we're going to come up on the left side, make a box, and come straight over. Okay? So this f value here, do you see is f at 0? Everybody good with this? Okay, and then I'm going to come over here and make a box using my 2. So this f value here is f of 2. I'm going to come over here on the left side, make a box that ends up being f of 4 as my height. And I'm going to come over here and make a box, and that ends up being f of 6 as my height. Okay? And so what I want to do is find the area of all of these and add them together. I trust that you can do that. But since you do have a calculator, when the problems get a little bit harder, what a lot of students do is they'll call this x and call this f of x. And you can go into your calculator. I don't think my calculator's on now. But you could put in, do a table format, you know what I'm saying, and make your table, change the auto to ask. And then put in your numbers here. So this would be 0, 2, 4, 6, 8. At 0, remember my function is x squared plus 2. So at 0, my y value is 2. You guys see where I'm getting this? At 2, my y value would be 6. At 4, it would be 18. At 6, it would be 38. And at 8, it'd be 66. Yeah. Is that right? Okay. And then you could just get all these numbers. So here I want f of 0 times 2. So it'd be 2 times f of 0. That's going to be my first rectangle, plus my second rectangle, do you see, would be 2 times 6, right? My third rectangle would be 2 times 18. And my fourth rectangle would be 2 times 38. And so I never used my last point. And that's the thing, right? If you do a left-hand Riemann sum, you'll never use your last point. If you do a right-hand Riemann sum, you'll never use your first point. Okay? Then you add all those together, and you get the answer. And unfortunately, I erased the answer. But whatever you get, that's your answer. Everybody good with that? Okay? Then you do a right-hand Riemann sum. Do you feel like you could do that? Yes. Okay. Let's answer this question. On the left-hand Riemann sum, is it going to be an under approximation or an over approximation? Under. Do you see the picture? So you would say it's an under approximation if they asked you. And what would be the reason? Because f is increasing and left Riemann sum, or left-hand sum. Okay, does that make sense, guys, of how you justify under and over approximation? Okay, right hand, you would do the same thing, and I have this in my notes. I'm trying to see, where does it get hard? Midpoint might be a little bit tougher, so let's do a midpoint. Let's skip that and go to a midpoint. If we went to a midpoint, so this should be 256, the right hand, just FYI, you can put that in your notes. If you did a midpoint, what would you get here? So again, this is a curve. I'm going to go 0, 2, 2, 6, 4, 18, 6, oops, that's 4, 6, 38, and 12, and go all the way up to 66. Now I have my points, so I can be a little bit more accurate. And again, you don't really have to be that accurate. Okay. If I did a midpoint, do you still need 4 intervals on the midpoint? Yeah. Oh, sorry, 2, 4, 6, 8. What did I do here? Where did I get the 12 from? Okay, sorry. All right, you want still 4 equal subintervals, okay? So what you're going to have to do is you're going to have to come up in the middle, right? So this is already 4. So you're going to have to come up in the middle right here. Does that make sense? What's the middle between 0 and 2? 1. Guys, so I'm not going to use 2 and I'm not going to use 6. What number am I going to use right here? If I plug in 1, what do I get? Yeah. So you actually do a little f of x like this, and you're going to put in 1, 3, 5, 7. You guys see, we're going to use different numbers for the y's for a midpoint. So if we put 1 here, this is going to be 3. Right here, the midpoint between 2 and 4 is 3. Okay, so you're not going to use the number 6. You're not going to use the number 18. Okay, what number are we going to use instead? Well, if I put 3 in here, this is x squared plus 2. Is that 11? It would be 3 squared. Yeah, that's 11. If you went to 5, because that's the number between 4 and 6, that would be 25 plus 2, 27. Do you guys see where I'm getting these numbers from? This would be 27, this would be 11, this would be 3, and then finally, I really think the midpoint's the hardest. If you come up at 7, okay, you're going to use 51. You guys see where I'm getting those numbers, okay? But then once you get those numbers, it's super easy. It's a geometry problem. What's the area of the first rectangle? That's going to be 2 by 3. What's the area of the second rectangle? That's going to be 2 by 11. Okay. What's the area of the third rectangle? That's going to be 2 by 27. And what's the area of the fourth rectangle? That's going to be 2 by 51. And then you'll add all those numbers together. Does that make sense? Okay. And you'll get the area using midpoints. And so guys, here I'm doing midpoint. And let me tell you the answer so you guys can check it. 184. Okay, and that's how you do that. Okay, so people are outside, but I think you guys get the hang of this, right? Midpoint, there's only 4 methods, left, right, trapezoid, and midpoint. Okay, good luck on your homework. It's going to be 1 through 6, and we'll finish 7 tomorrow.